Hey YouTube, so I'm back with another video for you because I actually had another project that I did and worked on for a while, and it's one of the more interesting fun projects I've done in the last little bit. Anyway, it's a type of transformer. It's a technically it's a DC to DC boost converter. This type specifically, it's called a joule thief in some circles. But it's actually a very simple circuit, and it operates on a very simple principle. So, how does a resonant transformer work? Well, so if you could imagine, you have your transformer core here, you have your one lead that comes this way, and then the other lead comes this way. So you have a center tap there. Now, from your center tap, you put a resistor of however many ohms. We'll say over here we have, say, plus 1 volt. And then down here, you come from here, you go to a transistor. And to ground. And now come here, and what I like to do is get a diode there so that the current can only flow in one direction that way. And actually, truth be told, the way that I do it, I use a bridge rectifier. So these two lines get tied together, these two lines get tied together, and a lot of times what people will do between these points is they will put a LED. To give off light over here. Now, it doesn't have to be an LED. It could be whatever other load. So what ends up happening with the way that these transformers work is initially nothing can flow through this. So what happens is a small amount of current will come up this way through the load, comes to the transistor. Now when it does go through the transistor, it opens it. So a lot more current can flow through the transistor down to ground. But as it does so, it reverses the current flow over here. So now, because this reverses, this gets shut off. And the momentum that the electricity developed coming through here, I'm calling it momentum. I know that's not the real technical term, but in my brain, this is momentum. So it's all stored inside of the magnetic field here. And when this gets blocked off, all of the energy that's stored inside of this magnetic field still has to go somewhere. And so what it'll do is the voltage that was pushing this current through is going to rise. So if this is the voltage curve, it might be starting here at 1 volt. But now when that transistor gets shut, it'll peak, it'll jump up, it'll rise, and then rapidly fall. And so using a system like this, you can take in very, very, very low voltage sources and step them up to extremely high voltages. And in my scenario with my device, I actually have the capability of stepping up as low as 0.6 volts to 95 volts. 95 volts because that's the limit of my transistor. And so once I constructed that, I did a little bit of experimenting and a little bit of playing. And right now, I actually have my resonant transformer up here. So I wound this nice big core around this torus. I have that potentiometer over there for setting the power output. And this normally runs on 3 batteries in series, but I decided that instead what I'd do is I would run it on 2 in parallel, or 2 batteries in series, and then those 2 banks connected in parallel. So they come into here on my breadboard, and they go to the common tap on the transformer. One leg goes to the potentiometer, and the other leg goes to the transistor. The output is fed through a full wave bridge rectifier and smoothed with that capacitor so that the voltage spikes don't burn out the little electronic board that's inside of here. Now, it runs this light quite nicely and has been running it now for close to 2 weeks, whereas running the light normally, because there is no power control, causes the batteries to die within about 24 to 48 hours of use. And right now I've got 7 times 24 times 2. It's been on for 2 weeks straight. And it's currently at basically the lowest power setting, but I can still crank it up and get it to go brighter. But I'm content to keep it just a nice little glow here. So like I said, it's been running on those batteries now for 2 weeks. It's a significantly more efficient use of the batteries than just that little triple slot right there. And then these LEDs over here, they exist specifically because if something happens, say this gets disconnected, then rather than going all the way up to 95 volts, this will cap it off at 18, and the LEDs will drain off any power in excess of that. So anyway, that's my Joule Thief. I think these are fantastic little circuits, and I have all kinds of little uses that I want to use this for. Some people have this idea in mind that a Joule Thief somehow can capture energy from the environment. And no, it can't. That's just not something that's going to happen. Unless you have a radio source that is operating nearby at a similar frequency as your Joule Thief is oscillating at, you're not going to be picking up any power because you're not resonating with anything. RF energy capture is real, but it's not done like that. This is just a more efficient way of boosting up the voltage from a low voltage source, and taking low voltage sources that can potentially provide a decent amount of amperage and turning that into something useful. Anyway, we'll see you, YouTube.